Hello everyone. In this video, we are going to discuss about POS reduction of Boolean expression using K-maps. You are going to see an example which explains in detail how to receive a question and how to identify the max terms and how to mark the max terms in the K-maps, and then reduce the variable and write the terms, and finally combine it and make an POS expression, minimized form of POS expression. Now you can see a question here. Find the minimum POS expression of the function f wxyz, okay, equal to this is the symbol we used for POS, okay, product of sum 0 1 3 5 6 7 10 14 and 15. Okay, so first you have to draw the K map, okay, with the labels wx and yz. So wx should be representing the first two variables. Okay, so you have to write the left hand side, that is rows, using the product of sum form. Okay, so you have to write the sum form here. So w plus x, and second row will be w plus x dash, and third row will be w dash plus x dash, and finally you will have w dash plus x. Okay, the gray code remains the same. So based on the gray code, you have to write the max terms. See here for yz, the gray code is same. Okay, you have to write the max terms for the variables y dash. So it will be yz. So y plus z for the first column, y plus z dash for the second column, y dash plus z dash for the third column, and y dash plus z for the fourth column. Okay, so once you mark the labeling has been done, you have to write the numbering inside 0 1 and 3 2, then 4 5 7 6, then you'll have 12 13 4 15 and 14, 8 9 11 10. So this marking is same as the previous SOP. Okay, SOP reduction using K-map. So K-map numbering will be the same, only the labeling will be different. Now you have to write zeros for the max terms being given here in the question. So you have 1 2 3 4 5 6 7 8 9 max terms. So you have to fill in according to the number. So it will be it has been filled in 0 1 3 5 7 10 14 and 15. So when you, after marking zeros, as usual, you have to compare it with the question and verify whether you have marked all the max terms. Okay, and write all zeros here. Okay, that is the difference between SOP and POS. Now after doing this, you have to fill it with remaining boxes with 1. Okay, so once you do that, the K map has been filled with numbers. Okay, now you have to go for octet. You have to check for octet. Here you are going to see zeros, whether 8 adjacent zeros are available. It is not there because you can see the first two rows, you got two ones here, so you cannot do that is, you cannot identify octet. Same way, last two columns also you have two ones here, so you don't have octet here. So finally you can conclude that there is no octet. So you have to go for chords. Check for chords. First row you can see three zeros, but you got one here, so you cannot make an chord here. And last column also you got three zeros and one, so it is also don't make an chord. Now but you can see here the second column, okay, of the first row, you have a square chord, so that you can mark it as an chord. Okay, so the chord will be m1 dot m3 dot m5 dot m7. So this is the chord you identified. Okay, so after identifying the chord, you have to check whether any other chord is available. You can see one more chord is here available. Okay, so it is 7 6 and 15 and 14, that is chord 2. Okay, so m7 dot m6 dot m15 dot m14, that will make a chord 2. Then you have two zeros, one in this corner and one in the top, that is first box. Okay, top row, first box. Now you cannot make any other chord because you don't have any zeros here. Okay, so what you can do is you can mark a pair here. Okay, that will be the pair which has been identified. So pair 1 is m0 dot m1. Okay, so and then you can also mark a pair because you cannot make a chord here, so you can make a pair. So that will be pair 2 m14 dot m10. Okay, so any you have to see that all these zeros has been marked, nothing has been left off. Okay, once you are done, you can reduce the expression. So you are going to see how to reduce the expression for pair 1. Okay, you got w and plus x, that will be same for both the boxes 0 and 1. So w and plus x will be taken, and you can see the column here, x is same for the both the boxes, it does not change its state. That is y does not change its state, but you can see that z changes its state to z dash, so you are going to remove z, so you will have y plus x plus y. So this is w plus x plus y, that is a reduced expression for pair 1. Now reduced expression for pair 2, you can see here w dash has been same for both the boxes, it does not changes its state, and you can see x dash is changes state to x, so you are going to remove x here, and you can see y dash and z will be the same for both the boxes 14 and 10. So you will have w dash plus y dash plus z. So that is the second, that is pair 2 reduced expression for pair 2. Now reduced expression for chord 1. Okay, this is chord 1. So here you can see w does not change its state. Okay, first two boxes, the w does not change its state, but you can see x is changing its state to x dash, so you are going to remove x. And also you can see y is changing its state to y dash, so you are going to remove y. So you will have remaining is z dash. Z dash is same for both the boxes, so you are going to take y plus z dash as the reduced expression for the chord 1. And then finally for chord 2, you can see you got w is changing its state to w dash, and you can see x dash is same for both the boxes, so you are going to remove w and you are going to keep x dash. And on top you can see w y dash is same for both, it does not change its state, but you can see z dash changes its state to z, so you're going to remove z, so it will be x dash plus y dash. So this will be the reduced expression for chord 2. So when you're going to combine all this, you will get an reduced, that is POS expression. Okay, you have to multiply all the terms, that's the difference here. You have to write w plus x plus y, okay, that is for the pair 1, and w dash y dash and z for pair 2. You have to multiply both the expression, that both the terms, okay, all the terms, not only both the terms, you are going to multiply all the terms to make it as a product of sum. Okay, then you have two pairs here. Okay, so this is how you are going to solve a question which is given to minimize the Boolean expression using K map and write the reduced POS expression. So hope you understood this video. We'll meet you in the next video. Till then, thank you.